Okay, I'll let you record it. That sounds good. We'll continue. I have no problem with that. So I've been working on for the past several months some new material on climate. When I came to St. Louis, you already assumed, since I had been at NASA, that I knew something about climate, but I really didn't know. And the best way to work, I knew some things, but after teaching a course that I've developed for the last 5 years, I do consider myself somewhat knowledgeable on the subject. So I want to share some of this with you. It's a slightly different take on climate than most of you have. And most of you, let's see, all of a sudden I can't forward it. Okay, so I usually use this as the first slide, which many of you recognize, Greta Thunberg. And she's an interesting young lady. And the main reason I put this on is that on the bottom is an answer to a question that was raised to her by Trevor Noah on The Daily Show. You know, what can we all do about climate change? And her answer was the most important thing we can do is inform ourselves and understand the situation. So I believe in my heart that I'm sort of fulfilling that prophecy by talking to audiences like the ones out there in Zoom land about climate change and learning using my knowledge that I've acquired over 50 years. I've been in St. Louis for 50 years ago. I started, I can't even believe that, and share some of that knowledge with you. Okay, next slide. Okay, you already know about my background. Everything on that slide is here. What you need to know probably is that we're going to talk about Paul Crewson, okay? And that's what makes this talk different than any others I've given before this time, because Paul unfortunately passed away in January. And Paul was my mentor, and I guess when you're so close to somebody for so long, you don't really realize how important a person is in the field of science. One of the other things I did after coming to St. Louis U was I organized a St. Louis Climate Summit as part of the St. Louis U bicentennial in 2018. And with the help of Peter Raven in particular, who knew everybody that there was to know in the field, just about everybody, we had an outstanding conference with about 22, 23 world-renowned class speakers. And if anyone is interested in seeing what it was, what happened, all of the talks that were given at that conference are available on the Channel 9 website. They're all recorded and archived. We partnered with Channel 9, and unlike many talks like you're seeing here recorded on Zoom, these were all professionally recorded with more than 2 or 3 cameras and good audio. So I'm not going to go back through this, but what I want to talk about now is humankind's influence on our environment. I've sort of broken this talk into 3 different components. Part 1 is going to be a tribute to Paul Crewson and the concept of the Anthropocene, because it is this concept that Paul first suggested that makes why we are, what we're doing to the planet so important and unfortunately not very good. And then I'm going to go into part 2, which is probably more of what you expected, which is going through an article that was written on Earth Day this year by the New York Times. And it really did a great job. So I'm sort of recapturing and adding to what are the facts and the evidence, and how do we know we're in the middle of some kind of climate change. And then last and by no means least is what many people don't realize is how there's been this very concerted effort to confuse the public and to put forth what became known as alternative facts under the last administration. So on the very first day of class, as I'm going to class, I received an email saying that Paul Crewson passed away in late January. It wasn't totally unexpected. He had not been in real good health. And shortly thereafter, there were several obituaries written about Paul. Well, this one appeared in Scientific American, which I think many of you who are a little bit interested in science are very familiar with. And I had to pull out this particular phrase, okay? Paul Crewson was not just one of the greatest scientists of his time, but one of the greatest scientists of all time. I mean, that's a pretty powerful statement. And it got me to thinking, you know, what was different about Paul that anybody would write such a statement? And, you know, there are certainly many, many great scientists, not just now, but you know, in all times. So one of the reasons, and I'll go into this now, which sort of separates Paul from the rest of the pack. Paul was awarded the Nobel Prize in 1995. He shared it with Mario Molina, who also just passed away a few months ago, and Sherry Rowland, who passed away in 2014. But basically, Rowland and Molina wrote a paper about the theoretical existence of ozone depletion from the fluorochlorocarbons, or you know, Freon, as it's commonly known as a trade name by DuPont. But if you read the citation, the Nobel Prize wasn't just given for what happened that resulted in the formation of the ozone hole. And I emphasize these words here, that it's given for atmospheric chemistry concerning both the formation and the decomposition. Of course, the decomposition refers to the ozone hole. But the formation was an area of research that I was able to work with Paul on. And again, very blessed to be able to be at the right place at the right time. So again, as most people thought, this classic paper, it's been cited more than any other paper in science, at least it was at one time, that was written by Mario and Sherry in 1994. It talked about the possibility of chlorofluoromethanes destroying the ozone layer. It wasn't until almost a decade later that we actually then saw this thing called the ozone hole develop. And indeed, one of the really bright spots about the fact that we've done something now to solve the ozone problem, it sets up a model for which we can get the planet together, the world together, and the contributing countries together to do something about climate change. When that will happen, hopefully it's sooner rather than later, but that'll be talked about later on in this talk. And then a paper that I wrote with Paul, and I'll refer to it a little bit later, my dissertation was on ozone in the troposphere, or the lower atmosphere. So it had to do a lot with the formation aspect of ozone. And Paul and I remained very good friends, you know, for many years. And this picture was taken in his living room with, that's the fake Nobel medal in my hand. The real one is solid gold. They keep in a safe deposit box, but they keep this one around to show to people. So let's look what else Crewson had done. So the research that he was cited for in the Nobel Prize citation was basically research that was conducted in the 1970s. In 1982, and I don't know how many people remember this, there was this thing called nuclear winter, okay? And it was the artifact of what may happen if there was a nuclear war, about all the smoke that would be generated. And basically, there would be no spring or summer. All the light would be blocked by all the particulate matter in the atmosphere. But Paul actually wrote the predecessor to that paper in 1982, okay? It became popularized in the mid-1980s, primarily by Carl Sagan and his colleagues that wrote another paper. What we're going to concentrate on is this paper that Paul wrote in 2002, in which he proposed this concept of the Anthropocene. And as if that weren't enough, Paul was a member of the Pontifical Academy of Sciences. He became one of the council members of the Pontifical Academy. And basically, the Pontifical Academy is a group of what they call academicians, and they advise the Pope on secular arguments. So he, being a member of the coordinating council, basically, there's 8 on that council, he and others convinced Pope Francis to, let's look at the impact of climate change on humanity. And if you look at that aspect of it, the concept of the Anthropocene comes forward. So what is the Anthropocene? Well, it's a period or geological period in the planet's history that Paul, in a meeting in the late 1990s said that we have left the current period. Okay, basically, you guys have heard things like Jurassic periods and Cambrian. I don't know the geology, but if you look at the time scale in terms of age of the planet, you go back 65 million years here. The last 12,000 years it has been an era called the Holocene. And why this is important is that the Holocene, covering the span of 12,000 years, I'll go into a little more detail later, mankind is only known living on this planet during the Holocene. And the Holocene is basically a freakish aspect of the climate cycles on the planet, which allowed civilizations, and in particular agriculture, to be developed, and civilizations to be developed over the last 5,000 or 6,000 years or so. So we'll come back to that in a little bit. In 2015, the Pope Francis, at the urging, not the urging, but in coordination with his Pontifical Academy, decided to release what was called an encyclical. An encyclical is a paper written by the Pope. Encyclical means letter, and in particular, it's a letter to all the bishops stating the church's stance on a particular secular issue, okay? So they had been working on this for several years, and it was announced that it was going to be released in June of 2015. There was a lot of talk about it, and it was released in advance of the Paris meeting of the Congress of Parties, the group that forms the IPCC, which was going to convene in December of 2015. So Pope Francis wanted to make it clear where his followers stood on the issue of climate change. Well, this was really met by a lot of disdain by a lot of the religious conservatives who, basically said the Pope's got no business to talk about an issue that is of no relevance at all to what the church should be doing. So I pulled this quote off of an article in the Christian Post from March of 2015. It says, Pope Francis's heart might be in the right place, but the earth spins, the seasons change, temperatures rise and fall, and surely God does not smile at the audacity of mere mortals, foolish enough to think they can affect a planet which is clearly under God's control. So the line in the sand is sort of drawn along that. Well, let's look at what Ms. Bass and the other conservatives are talking about. So natural climate variability can be explained by, for the most part of the past million years or so, by variations in the Earth's orbit and other planetary parameters. And the man who worked this out was a Serbian mathematician, Milutin Milankovic. And he was a mathematician who worked out equations for several parameters that affect the planet. And the three parameters he looked at were eccentricity, obliquity, and precession. Eccentricity is the fact that the Earth's orbit is not circular, okay? It's elliptical. Newtonian mechanics says that two bodies rotating around each other will do so as an ellipse. The two bodies, in this case, being the sun and the Earth. Under special conditions, that ellipse degrades to a circle. But even now, we're slightly elliptical, and we're closer to the sun in January, okay, than we are in June. Okay, so we're closer to the sun actually on January 3rd, which is winter time in the Northern Hemisphere, but it really doesn't have that much an impact on climate, on the seasons per se, but these cycles do take place. And what Milankovic said was these cycles become more elliptical over periods of time. Being a mathematician, that's what he solved for. Obliquity happens to be the tilt of the Earth's axis. Right now we're at 23.5 degrees. That's the tilt of the axis relative to the sun. That varies over a function of time. And the last component to be looked at is what's called precession. And we know very simply, as the top rotates, you've done this many times, you spin on top, it wobbles. So the Earth also wobbles. So basically, what Mr. Milankovitch did was he solved all these equations for the obliquity, for the precession, and for the eccentricity of the Earth's orbit. And you look at it from now, and he was able to solve these equations and look at how they vary in relation to time going back a million years. Well, as these cycles overlap each other, you're going to have the amount of heat reaching the planet Earth variable. And basically, if you put all of these cycles together, you end up with this graph down in the bottom. And basically, what you see is that now versus 100,000 years ago, several 100,000 years ago, you have periods of warm, which are denoted by the gray areas, the shaded areas, and colder areas, which on timescales of thousands of years, tens of thousands of years, promote glaciation. This is when the glaciers form and then eventually can come down to North America. So Milankovitch cycles are an important part of climate, and they controlled climate more or less over the time scales of a million years. So let's look at this in a little bit more detail, okay? And what we see is, this is reversed a little bit, now is on the right-hand side, and we're right now in a warm cycle, okay? And it's a stable warm cycle. 80,000 years ago is another warm cycle, et cetera, going back to 400,000 years. So you can see how the temperatures, which are denoted by this red line, okay, looking at delta temperature as a function of degrees Celsius, does vary on the order of about 10 degrees Celsius or so, and that does have a big impact on climate. When you look at the ice cores from which these data are acquired, you also see that the concentrations of carbon dioxide, which scientists can recover from the ice core samples, also vary, and they vary very well, precisely almost, with respect to temperature. So higher CO2 concentrations are found when there's higher temperatures. And this is what the old argument is, and it's still a valid argument on these timescales. If we expand this and now look at just what's happening in the last 100,000 years and then focus on the Northern Hemisphere, we see, again, climate change, but let's focus on these first 12,000 years before present. Two things you notice. In the Holocene, we're at a relatively warm spell, a very warm spell. But more importantly, climate is very steady and very stable. The important aspect of this is humans didn't come onto this planet and civilizations were not formed at any time prior to the onset of the Holocene. For about 12,000 years, we've had sort of like a perfect situation where mankind has developed civilizations. The big invention during this time was agriculture. So man went from being a hunter and gatherer, primarily eating meat, to being able to grow grains. And then as civilization evolved, you could form villages and you can come to a central place to buy those grains. And that's what all civilization is on top here. So what Crewson has said now is that we are coming to the end of the Holocene, we're coming into a new era. I want to go one more time, and even though we see going back 600,000 years, this oscillation of temperature as denoted by what's called deuterium ratios, but let's not worry about the details of that. The variation of carbon dioxide, the variation of methane, and these are two different temperatures by which two different graphs of at the derived temperature. The one thing to keep in mind is that yes, we have a correlation of carbon dioxide with temperature, but the range of those concentrations were limited to 280 and to 180 to no more than 280 parts per million. That's this scale over here. Now let's expand this one more time and look what's happened in the last 160,000 years. And basically look at carbon dioxide. All of a sudden, at some point, we have exceeded the amount of carbon dioxide in the atmosphere that was never before ever seen in the recent geological history. So we're now at about 410. This graph's a little bit old, but we're at about 410 parts per million of carbon dioxide. So we've exceeded that natural limit of carbon dioxide. And indeed, that's what the Anthropocene is all about. If we go in more detail on these carbon dioxide concentrations, according to Crewson's analysis, the onset of the Anthropocene was corresponding with the onset of the Industrial Revolution. And you can see prior to 1700, we were still below that 200 magical number of 280 parts per million, but then we gradually got above it. And in this concept of the Anthropocene, they start talking about the period of 1950 onwards, post-World War II. This is called the Great Acceleration. You see this in the carbon dioxide concentrations. And these are very well documented with a lot of extensive measurements at the Mauna Loa Observatory and other places around the planet. So we know that this concentration is very accurate and meshes very well with the data that were taken from samples. So if we look at the, again, Paul was an atmospheric chemist. I was trained by Paul as an atmospheric chemist. We look at 3 trace gases, we look at carbon dioxide, we look at methane, we look at nitrous oxide. They all have this characteristic shape of what we see in the Anthropocene scenario. You can look at temperature, okay? And it's not a perfect match, but again, you see a same general type of constant there. We can look at flooding on the planet. Again, you see this slow increase and then this rapid acceleration post 1950. We look at the ozone depletion. It didn't exist before 1970 because there weren't chemicals manufactured that depleted ozone. Again, it's a little bit stretched, but again, you could say that the Anthropocene cycle falls in that. We look at how land has been converted, clearing for a forest to make things, wood products for herding of cattle and sheep. Again, it has that same characteristic profile. And I think one more here is looking at the aspect of global diversity, which is, if you go more into detail of the people who study the Anthropocene, they believe that this is the most important thing that may be most detrimental to the planet. Now let's look at what we call the human enterprise and look at the curves for this. And I've highlighted a couple, but certainly we look at water usage. Again, going back before about 1900 or so, relatively small, relatively constant. It accelerates post 1950. We look at paper consumption. We certainly are aware of the use of a lot of paper now. It's probably going down a little bit now as we learn to do more things electronically. We look at something like motor vehicles. That's very obvious. No motor vehicles before 1900, very few until 1950. And this curve takes off at that point as well. Population follows this curve, but more importantly, urban population is really accelerating much faster than human population on the planet. And this, with its aspect of societal implications, is putting a societal strain on our planet because of the inequities in many of the urban areas. And this is talked about a lot in the Pope's encyclical. But again, it is a very important part of what the Pope is saying. And the whole thesis behind the encyclical is that the planet is ours to care for, and it's up to humankind to take care of it. So urban population is a really big focus of, and also care for the poor, which is a very common theme within the Catholic Church, and in particular within the Jesuit Society, which Pope Francis is a member of. Okay, so let's go back and look at what we're talking about, okay? So today's climate and its associated changes are consistent with the dawning of a new geologic period, which we call the Anthropocene. So we're ending the Holocene. This is what Crewson alluded to in his paper in 2002, and we're now entering the Anthropocene. And the geological community is looking at this. I'm going to throw in a little bit of a side note here. When Paul and I did this paper in 1977, we talked about ozone in the troposphere. It was a theory at that time. Subsequently, in 1994, Elaine Marenko published this paper. And indeed, if you look in the background atmosphere and you look at the concentrations of tropospheric ozone, and Paul had this sentence that this is certainly just Paul's wording in that paper. And he said, the idea we came up with was looking at the differences between northern and southern hemisphere. So this is in there. It says, if significant tropospheric ozone production takes place, it follows that the concentrations of ozone in the lower troposphere, where we live, in the northern hemisphere have increased substantially since the inception of the industrial era. Again, at that time, when the paper was just a theory, it wasn't until 20 years later when these kinds of analyses were made available. And it may indeed be the first comment on the onset of the Anthropocene. So I pardon my indulgence in that. So now that we sort of have a setting for climate change, I'm going to summarize some of the key components of a paper that was just written last month by young author, Julia Rosen. I assume she's young. Most people are younger than me. On this, it's a really good article if you have access to the New York Times. But basically, it's the science of climate change, explain the facts and the evidence and proof. So I want to go through that with you. That'll take about another third of my talk. But again, she does emphasize in the paper, in her New York Times paper, really the concept of the Anthropocene right here. The Industrial Revolution, people started burning coal and other fossil fuels to power factories, smelters, and steam engines, which added more greenhouses to the atmosphere. And ever since, human activities have been heating up the planet. So if we look at the actual carbon dioxide emissions from fossil fuel, again, this goes back to the 1750s. You see maybe a little bit of a deviation by the end of the 19th century, but things stay pretty constant. But here we are again, 1950, things really heat up. So again, that same curve that dominates the Anthropocene is present in our use of fossil fuels. Not really surprising. And again, she emphasizes in her article that the warming is unprecedented in recent geological history. And she refers to what's called the hockey stick. Okay, Blues maybe could have used this, but this was published in one of the IPCC documents, I think in the 2007, the AR4, I'm sorry, atmospheric AR, the assessment review number 4. So in 2007 it came out, and this is what the article is published. And again, it goes back about 2,000 years. You see a relatively steady temperature. There's a brief cool period, which is known as the Little Ice Age. But then from the beginning or the middle of the 19th century, things have really gone up, and they've gone up quite a bit, okay? And you can explain, these have been characterized by the Little Ice Age in the early 19th century and for a couple of centuries beyond that. And the medieval warm period. Again, this was sort of emphasized by the climate deniers that we've always had some kind of climate change, but it's never been like this before. NOAA has been keeping pretty detailed records over the, since 1880. So we now have a very good, well understood records for 140 years. This is the latest analysis they've done for the year 2020, which shows that 2020 is the second warmest year on record, right behind 2016. But more importantly, the warmest 5 years, or 6 years now, on record are the past 6 years. So there's certainly a trend that's going on. It's almost irrefutable, even though I'll show you later, there was a move to try to show that nothing was really happening. And if we look at the warming, this is now looking at the temperature difference on the planet relative to the average temperature of the 20th century. And what's important to notice here is that there's much more warming at northern, middle, and high latitudes than in the tropics or in the southern hemisphere. And this is significant, and I'll go into that later because this temperature difference, the difference of the difference is very important for changing the weather patterns, and we're seeing some of the results of that now, okay? I just put this in just to show you that warming is not uniform everywhere. This just came out in the last couple of weeks of looking at 20 data relative to the 20th century average. And again, you see certain regions, in particular Alaska and Southern California, but even in the last century or so, there's a relative cooling effect in the Southeast. And most of that is probably due, well, it is due to the increase, the warmer temperatures allow more water vapor to be in the atmosphere. You get more flow off the Gulf, you have more cloudiness. So overall, you see somewhat cooler temperatures and less warming in the South the Southeast relative to other places in the country. This is an important figure also, because this is now looking at the heat that is being generated by that excess carbon dioxide in the atmosphere. And it's important to realize that most of that heat is in the ocean, okay? And again, this is data going back to 1950s or so. And you can see this steady increase, and there is sort of an inflection around the turn of the 21st century. And more importantly, when you look at the distribution of that heat, most of it's in the ocean. This brownish reddish area is what's in the heat that's stored in the atmosphere and on land and in ice. But over 90% of the heat that has been added to the planetary system is in the oceans. And that has significance too, because it means even if you turn off all emissions, theoretically all the CO2 emissions, you're still retaining a lot of heat in the water. The water is still going to radiate that heat back to the atmosphere. So it's a process that's not going to go away no matter what you do immediately, but we have to start taking steps to do that. This is again from the New York Times article. It's showing the decrease in ice content, ice amount over the Arctic. We're looking at the March timeframe in the blue line, the September timeframe when less ice is melted on an annual basis. But there's no doubt a downward trend, okay? With 2012 being anomalous cold. As a matter of fact, there was a rebound in the ice content between 2012, 2013, 2014, which again, some of the climate skeptics used as proof that there was no such trend. But when you look at the trend in a larger time scale, we're using surrogate data versus satellite data. Again, satellite measurements of these kinds of phenomena are date back to about 1980 or so, because that's when the Earth observing satellite system was put into effect. But you go to surrogate measurements of ice extent prior to that, okay, going back 1,000 years, you can see not only is a decrease there, but it's also very substantial to a certain amount, somewhat frightening. And you can actually extrapolate, if you want to extrapolate this curve, you can say, well, by some year, probably by the latter half of the 21st century, there's not going to be any ice in the Arctic. So that's going to also change dynamics quite a bit. Because of the ice melting, we're also having sea level rise. And again, going back to an instrument that was flown by NASA called JASON, launched in the early 1990s, we see this constant rise in sea level. It's 3 millimeters per year. Okay, it doesn't seem like much, but that's 3 centimeters per decade, which now we're talking about over an inch. And it's not going to take very many decades to reach levels. And having lived in Virginia, very close to the water, across the street was one of the tributaries of Chesapeake Bay, that 6 inches or 12 inches difference does make a difference, because whereas we didn't have flooding very often at all, we now had occasional flooding associated with strong storms off the coast and hurricanes. So you hear about what's happening in Florida with the king tides. Even in cooler weather, because the sea level is higher, You have flooding in the streets of Miami Beach, even when there's no storm involved at all. So these are the kinds of things that are going to happen. The article goes on to state that there is a consensus, and I'm going to emphasize this later, about climate change. And it sort of summarizes this statement here. I hear this a lot. 97, more than 97% of the publishing climate scientists agree on the existence and cause of climate change. I don't know where 97% comes from. I think it's more like 99 plus. Anybody who studied the problem knows that there's something happening, okay? So this brings me to the third part of my lecture, and that is the concerted effort that has been underway for the last couple of decades that is confusing the public and sort of stems from, I don't want to give this guy too much credit, but this is a statement taken from his radio show around 2011, and I'll just read it. It says, I've instinctively known from the get-go, from 20 years ago, that climate change is made up, and the reason I know it is because the liberals are behind it. Now, this is interesting because look what Ronald Reagan said in 1984. Preservation of our environment is not a liberal or conservative challenge, it's common sense. Margaret Thatcher, no doubt a conservative leader of Great Britain, said, what we are now doing to the world by adding greenhouse gases to the air at an unprecedented rate is new in the experience of our Earth. It is mankind in his activities which are changing the environment of our planet and damaging it in dangerous ways. President George H.W. Bush in 1990 said in remarks to the IPCC, the Intergovernmental Panel on Climate Change, we all know that human activities are changing the atmosphere in unexpected and unprecedented ways. So this goes back 20 years prior to when the statement was made by Mr. Limbaugh. So what happened in between? Several things, okay? And in the New York Times article, it's points to what's called the Global Warming Petition, also known as the Oregon Project, whereby it is claimed that 30,000 scientists signed this petition stating that there is no such thing as climate change, okay? The Oregon petition, this is in detail. They claim they had 31,000 scientists sign it, most of them with PhDs, blah, 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 blah. And this was distributed right before, or not sure right before, but before the Senate was to take a vote on whether or not the US would become a member of the Kyoto climate agreement, okay? And basically there was this mass flooding of misinformation and the gathering of names that was submitted to Congress, to the Senate in particular, stating that, you know, it's not true. There is no such thing as climate change, and here's 30,000 signatures that agree with what we're saying. Turns out a lot of these names were forged. Very few of them, they said 9,000 had PhDs. Very few of them had any PhD in atmospheric science or climate or whatever. But anyway, it worked, okay? The US never became a signatory to the Kyoto Protocol. In 2013, the IPCC, the Intergovernmental Panel on Climate Change, issued its 5th assessment report. The first four done in 1990, 1995, 2001, and 2007. But the 2013 report was definitely the most comprehensive. And then subsequently, a project funded by the Heartland Institute, a group that was called the Non-Governmental International Panel on Climate Change, the NIPCC, put forth a report that looked very much like the IPCC report. It was about 1,000 pages long. The IPCC report was about 1,300 pages long. And basically they circulated the summary of this report, because that's how I know about it, to show, you know, and using statements like, that models used to justify global warming, alarmism, are full of fudge factors and do not begin to describe the real world. Well, in my class, I go through this report and show how all these factors are all wrong. But if you're not a scientist, it's easy to believe. And I'm going to go to a side story real quickly. A couple of years ago, every year, my son and I, as part of the Fragile X advocacy group, we go to Washington, D.C., and we advocate for the rights of the disabled. And in 2019, I believe it was our first time of meeting with Josh Hawley, and he was a new senator and very cordial. And we met with him. But as I was leaving his office, which was still under construction because he'd just been elected a few months earlier, I noticed this report that was being marked, and it looked like it was being read by his staff. And senators and congressmen have staff members to keep them informed. And I wrote a letter to his staff and to Mr. Hawley himself, saying, please do not read or do not believe what's in there. And I never really got much of a response, but obviously climate change was not a big portion of Senator Hawley's agenda. And of course, since that time, he's gone on to other issues that he thinks are more important. But anyway, one of the things that the NIPCC did was that they looked at the hockey stick, okay, and they claimed in this document, actually before this document, that this analysis was incorrect. And they said that there are factors in there that are not taken into account. So they gave, I was told, $600,000 to a man by the name of Richard Muller to do his own analysis, the correct analysis, to invalidate and to show the weaknesses of the curve that was generally accepted by the scientific community and produced by NOAA. And basically they're saying that the temperature histories are all biased by the urban heat island effect, blah, blah, blah. And Dr. Muller, who was a MacArthur Fellow, which is a nice honor to have as a scientist, but he was not a climate scientist. He was not an atmospheric scientist. He was a physicist at Berkeley, University of California, Berkeley. I'm going to go back, he said, and reanalyze this data. And he did that. And he got paid, like I said, $600,000. And here's what he came up with after he did his analysis. After years of denying global warming, Dr. Muller now says that global warming is real and humans are almost entirely the cause. And in his conclusion, he states that the temperature record that showed global temperatures were not only driven by human activity, but most totally can be explained by anthropogenic emissions. And there's also the impact of volcanic eruptions, he said, may be important. And you can see that in the data a little bit. What we need to point out in his analysis, which is the black analysis, the NOAA analysis is in green, the Hadley analysis is the Brits, Berkeley analysis is his, NASA does their analysis, it's in the blue. They all sort of fall on upon each other. The Berkeley analysis, Muller's analysis, goes back an extra 100 and some odd years, and they try to reconstruct this data set between 1750 and 1880. And they do so, and as you can see, it's very noisy. The gray represents the noise. And his volcanic activity is basically some of these low temperatures that was found in conjunction with the massive eruptions of Mount Pinatubo, I'm sorry, not Pinatubo, Mount Tambora and the Krakatoa eruption in 1883. So he basically, took their money and said, I made a mistake. So a really good book that describes this concerted effort of misleading the public. It was written by Naomi Oreskes. She is a professor at Harvard University, and she wrote this book called Merchants of Doubts. And there is a movie that was made out of this. If you're interested in looking at how we've been deceived, it's really strange because the people who said that smoking wasn't harmful to your health are also the people who said there is no such thing as climate change. So I'm going to show a little bit of a clip, I hope, if I don't get things too messed up here. This is testimony before the Senate Science and Technology Committee, which is headed by Senator Cruz. And the person testifying is David Titley, who is a retired admiral from the Navy who's in charge of looking at the impact of climate change on the military. So I'm going to see if I can do this without losing everybody.
You took a moment to address what you
can hear it. We got a new share. Share, and hopefully we can see this now.
Yes.
Okay, whoopee.
Described as the so-called pause in global temperatures. By the pause, are you referring to the last 18 years of no significant recorded warming?
Unlike your previous witness, I'm not referring to the 1940s. It is, I thought you'd like that.
Indeed.
Yes, the pause is very interesting, as you know, sir. 1998, big El Nino. So it's kind of interesting we started 18 years. We don't look at a 15-year data set or a 10-year data set or a 20-year data set. We look at an 18-year data set. But even if you do that, that's fine. Let's look at that. We have, this is low budget here. I got to do my own charts.
Well, let me take a moment on.
So here's, sir, just to answer your question, Senator. Here was 1998, and here's today. So on me, I mean, I'm just a simple sailor, but it's hard for me to see the pause on that chart. So I think the pause is kind of coming.
Do you dispute the satellite measurement?
Let's not talk about the satellite. Here's
but okay, sir, I'm asking, do you dispute? I understand that the global warming alarmists don't want to talk about the satellite data, but I'm asking.
Satellite. Let's talk about the satellite measurements. Let's talk about orbital decay. Let's talk about overlapping satellite records. Let's talk about stratospheric temperature contamination. I think Dr. Christie and Dr. Spencer, when they've put this out, they have been wrong, I think, at least 4 consecutive times. Each time the data record has had to be adjusted upwards. There have been several sign errors. So with all due respect, sir, I don't know which data exactly your staff has, whether it's the first or second or third or fourth correction to Dr. Christie's data. We used to have a negative trend, then we had no trend, and now we begrudgingly have an upward trend. So looking at those data, you know, it's okay. But here's where we live.
Let me see if I can understand the first argument you gave in response to this. And it is an argument that a number of the global warming alarmists use, is they say, well, 18 years ago was El Nino, and it's arbitrary to begin there. And I will confess, I don't understand that argument, because we have 18 years of no significant warming. So if you don't like an 18-year window, we can start in 1999. There's no significant warming for 7 years. If you don't like a 17-year window, we can start in 2000. Then we don't have a significant warming. It is true for any date across those 18 years. So I fail to see the significance.
Actually, Senator, it's not. If you take off that top really big spike and you take that out, you start getting the upward bias. And this is what people do when you start looking at these relatively arbitrary times, is you start with a really high number at the left-hand side, and that kind of influences your basically your linear trend. So when you start looking at things like every decade, you have an upward trend in the data, and that's from the World Meteorological Organization.
And I would note, you asked about the source of the data on the right chart. It's actually not Dr. Christie's data. It's the remote sensing systems, the RSS data that is up there.
Okay.
Yes, we're back at your PowerPoint, so this is good.
Okay, so you heard the argument that Senator Cruz was making, was pre-Beard, I guess, back in 2015. And then the rebuttal by Dr. Titley. And basically what he is saying here is that this pause, you know, you gotta be really arbitrary. And here's the global warming hiatus, as it was called, around 2014, 2015. If you extract that information, and as Dr. Titley said, look at it on a decadal basis, okay, and this is now every 10 years of data going back to 1880, you certainly see that there is a trend as opposed to just trying to cherry pick that data. Another part of the analysis is that we do know that global temperatures are warming during what's called El Nino years. I'll save that for another lecture. But if you look at the trend just for El Nino years, you're looking at this orange line. If you look at the trend for just the La Nina years and you take out when volcanic activity influence global warming trends, and the trends are quite similar. They are offset by a little bit, but a lot of that is due to the fact that the warmth of the ocean during El Nino is being transferred to the atmosphere more efficiently. But we'll not get into that. I'm not going to present this last video, but basically in January 2015, another senator named James Inhofe from Oklahoma brought a snowball into the Senate and said, well, how can there be global warming? They just undergone a big, substantial cold snap in the eastern US. And again, that can be explained a little bit by, not a little, it can be explained entirely by global warming. And I'm not going to go into a lot of detail, but there is an answer to it. And it's based on the fact, and I showed this earlier, the fact that there's more warming at the higher latitudes than at the lower latitudes. So here's your high latitude warming trend. And since the 1990s, your global average warming trend. The fact that you're warming the higher latitudes more than the lower latitudes results in overall a weaker jet stream. So there is this property in the atmosphere called the general circulation as a result of some fairly sophisticated thermodynamics and kinetic equations on a spinning platform and uneven distribution of heat. You form the jet stream. So the jet stream is a permanent feature of the atmosphere. It generally transports air from west to east. You've heard of the prevailing westerlies. And what's happened is that because you are now warmer, relatively speaking, in the northern and the high latitudes than it used to be, there's less of a temperature difference between higher latitudes and middle latitudes. And this is shown in this graph here that over the decades, going from the 1980s, this analysis stops in 2012, you have more resonance frequency. So what this basically refers to is the fact that the north-south component, okay, the wind speed along lines of longitude, that's the northern component, has become stronger, even though the winds have become weaker in general. And they are stronger than the north-south component. They're wavier because of the uneven warming effect. And so you heard the term polar vortex. There's an example of it in December 2018. 1 month later, you're seeing that jet stream, which you can sort of depict by this white line, the path of it, it's changed, okay? And basically what we talk about in the layman's terms, the breakdown of the polar vortex is very hard, cold core of air at polar latitudes, starting to invade lower latitudes. Schematically, it looks something like this. Because the jet stream has been wavier, it allows the cold air to move down farther into the middle latitudes. That's what affects the United States. This is an example from 2014 when you had a polar vortex sort of break down, but basically it's just that real cold air from polar latitudes. And this shows you, you had in the upper Midwest temperatures as much as 20 to 40 degrees below average. But again, it is a manifestation of climate change, and a somewhat subtle one, but it certainly can be explained by the fact of global warming. So that sort of brings me to the last part of part 3. And I just finished reading a book called The New Climate War by Michael Mann. He's given credit for the hockey stick. He's a climate scientist. He's well respected at Penn State. And he said that there is hope. There are signs that things are turning around. And these are some of the parts that some of the specific points that he's pointed to. Number one, the major investment funds are starting to take their money out of any kind of stocks that support fossil fuel companies. He points to the fact that over 1,000 colleges have divested over $11 trillion in fossil fuel holdings. The Heartland Institute's climate conference that they've had every year for the past 10 years had to be cut to just one day in 2019, even though it was held at Donald Trump's hotel in Washington. His meetings had been 3 days long. He points to this fact here, which is sort of interesting. The GOP messaging guru says, I was wrong in 2001. We need to put politics ahead of policies ahead of politics. Even the lawyers for some of the major oil companies, there's a lawsuit of the cities of San Francisco and Oakland versus all the major oil companies for causing dramatic impacts to the human enterprise. And even now the lawyer for Chevron says fossil fuels are the problem. So these things are starting to come around. And he points out a couple more factors. Renewable energy capacity is now 250 megawatts, which is about 20% in the US. And it's now cheaper to build power plants running on solar and wind than fossil fuel power plants. And he also points out to what happened during the pandemic. And you know, if we would have listened to science, if the administration before Mr. Biden had listened to science, and it's really estimated now several 100,000 lives could have been saved. So now he feels that it's important, you know, science has the public ear, okay? And he sort of concludes with this statement here: educate, educate, educate. The battle to convince the public and policymakers is for the most part over, okay? The substantive public debate is not about the fact that there is climate change. It's just about how bad will it get and what can we do to mitigate it. And the last sentence in his book says, hope is a good thing and maybe the best of things. Alone it won't solve this problem, but drawing upon it will. So Michael Mann agrees with Greta Thunberg: educate, educate, educate. That's exactly what she's saying. The most important thing we can do is to inform ourselves and understand the problem. I hope I listened to me for the last 50 minutes or so. You understand the problem better, and I don't need for you to become an activist, but I need for you to, I think, pull together and try to solve the problem as best we can. So I'm gonna stop here, and if there's any questions, I guess I'll be ready to answer them.
Sure. Let's go ahead and if you want to unshare your screen so we can see the whole audience, and then
Is that it?
that's great, great. So does anyone have any questions today? There was so much information. It was so very filled with lots of good information today. Dr. Fishman, we really appreciate that. Francine, do you have a question you want to unmute?
What you were saying about the universities divesting in fossil fuels, those of us who have money in funds, and I'm sure you probably do too, how are you doing your investments to avoid that kind of thing?
I'm not muted. I haven't yet, okay. But you know, most of my personal investments are with through the university system, and I haven't yet. I haven't tackled that problem. I did buy an electric car though, which I think is contributing to helping climate change a little bit. Right now, quite frankly, I've got other issues, but you're right. I should do that. Okay.
Well, I've been grappling with it myself. That's why I asked.
Yes, John, you want to unmute yourself?
Hi, Jack. It was fascinating, totally educational, and I hope I could understand 20% of what you said. But even with the more positive outlook in the United States, this is a global problem, and we have so many countries, India and China, that are huge polluters. And those are just the first two that come to mind. They're probably the most scurrilous of them. And is there any hope for the planet?
Well, the short answer is yes. India and China did sign the Paris Accords, and China in particular is getting fairly aggressive because insofar as trying to combat climate change, because they've got such a monstrous pollution problem. All this stuff they put in the atmosphere is killing their people. And I know that India, you know, is also looking at ways of solving the problem. everybody, with the exception of the United States, is on board with trying to reach goals of abating the amount of CO2 they put into the atmosphere. So it's not a simple problem, but we have to have hope. I think that last sentence that Michael Mann says, we have to have hope that it will change. I didn't get into in the whole book that Michael Mann wrote is that the whole stance of the climate deniers is basically what you're talking about, is to try to put the fact that, you know, there's nothing we can do about it, even if we want to do something about it. So they've changed their tune in the last several years because they realize that the facts they put out, the alternate facts they put out, they're all being disproven. There's really no more to prove to show that it's a human enterprise that is changing the planet. And again, I wanted to really emphasize the work of Paul Crewson, because he's the one who observed that. Maybe he is, you know, one of his whole concept of the Anthropocene is maybe the most important concept that the planet has to abide by. That we are now a force to change where we live.
Thank you.
I don't
The problem is, at least part of it, as I see, we start our charts at 1900, when the population of the world was less than 2 million people. And we come to 2021, where the population of the world is almost 8 billion. And by 2050, which is the date we're all talking about, it's going to be 10 billion. And all of those people want air conditioners and cars and electricity and nice houses and everything. And the world population problem is going to continue no matter what. People talk about cutting back and that we have to make an effort in this country. And yet you look at our highways and they're filled with SUVs and big BMWs and Mercedes, and it's good that you have an electric car. If all of us had small cars like you see in Europe and Israel, that would be better. But people aren't willing to give in to their daily, and I'm included, into their daily lives by cutting back. And your statement about China puts more CO2 in the air than the United States, the European Union, and Russia put together. Yes, they're making an effort, but their attempts have not been very successful so far.
Thank you, Bob. Do we have any more questions or comments? I'd like to go ahead and turn this over to Cheryl Adelstein, Deputy Director of JCRC. And I believe you have a few comments you'd like to make. You need to unmute.
You'd think I'd know better by now. Hi, yes, thank you. I just want to quickly thank Dr. Fishman. This has been so fascinating, and we really appreciate the opportunity to learn with you and from you. The JCRC is a co-sponsor today, so we thank the Mirowitz Center. I just briefly want to share my screen, if it works, to show that, can you see this? November 2020, Protecting the Environment?
Yes, we can see that.
Great. So the JCRC is an organization that has 33 member organizations, and we develop policy positions. And in November 2020, we adopted a new policy position on protecting the environment, where basically we have basically done what Dr. Fishman has said. We say the scientific consensus on climate change is real. People are already feeling the effects. And what is our call to action? Well, of course, there's a Jewish commitment and component to environmental stewardship, and that our JCRC is taking it. Our immediate priorities are going to be to focus on climate change and environmental justice. And so we'll be joining with existing environmental protection coalitions, participating in education programs like this one, and advocating for policy and other legislative changes to try to slow climate change and improve our environment. We also are, and I'm going to stop sharing now. This is on the JCRC website. So if you ever want to take a look, I will put that in the chat. But I'm doing that right now. If you want to be engaged in this work, if you connect with me, we are going to be thinking about over the summer how to jump into this. And another big priority for the JCRC will not just be climate change, but also environmental justice and the work around what needs to happen in our urban areas, because climate change is disproportionately impacting people of color in our urban areas. That's a whole different presentation. So Dr. Fishman, thank you for this amazing introduction, and we look forward to continuing to connect with you, and thank you, Merowitz Center.
Thank you, Dr. Fishman.
So can I give a quick advertisement? And I alluded to it a little bit earlier, but when we ran the St. Louis Climate Summit in 2018, the primary motivation was based on using the Pope's encyclical and trying to expound upon what he says there. And if you read the document, and I don't expect a lot of people to read it, but it's not that long, there's a big overlying issue, exactly what you're talking about, the environmental injustice, the social injustice. We saw it with COVID-19. It impacted the poor more than it did middle class. And it's a thing I'm interested to see what the Jewish Federation comes up with, because it sounds like it's very much in line with what the Catholic Church has come up with. And like I say, if you look at the other, some of the other talks, we had a whole session on a couple of evangelical speakers talk at the Climate Summit. So you might want to see what they're saying insofar as what the moral obligation is of not just the Jewish community, but the Catholic and the Protestant community as well. So that was just a little footnote there.
Thank you so much. Thank you so much again. It was a really very informational and educational program today. And I know it took a lot of work, and we really appreciate all the work you put into this. Thank you so much. Thank you everyone for being here today. We'll say goodbye for now.
Bye.
Thank you.